Most likely it will be in the lecture hall. All right, they reminded me that we need to cover Atwood's machines with energy. So Atwood's machines with energy, the technique is you're going to have a mass on a flat plane. I'm not going to get cute or anything with slopes. So initially this thing is at rest. It's initially at rest. There is friction, and when it ends its motion, this one is about to hit the ground. It is a particular velocity. There still is friction. This one moved down length L. This one moved over length L because they're joined by string. Also, both of them will have the same velocity. If they didn't have the same velocity, the string would either snap or it would bunch up. This is the initial position. This is the final position. The only thing that happens is that since there is friction, boo friction, the initial energy minus the work, the energy removed through friction is equal to the energy final. The initial energy is all potential. Why is there no kinetic energy initially? It's not moving. So you don't have to worry about that. The energy final is all kinetic energy. This mass went down to the ground, so it has given as much potential energy as it can. But M1, which is, though it's higher, it never changes its height. So there's no change in potential energy. So you can just ignore that part. So the initial energy is M2GL. The final kinetic energy is 1/2 M1 plus M2 V squared. The energy removed through friction is we go through our usual mantra of sum of the forces vertically is equal to 0, which is Fn minus mg. So Fn is equal to mg. Friction force, which is mu sub k, Fn is mu sub k mg, and work is force times distance, so that value is mu sub k mgl. The distance is L, the friction force is mu sub k mg. So it is minus mu sub k mgl is equal to this. What I would do now, and that's M1. The only thing to fall is M2, so there's only an M2 in G and L. M1 is the only one that experiences friction, so it's the only one in mu sub k mgl. They're both moving at the end, so it's 1/2 M1 plus M2 V squared. Now this is where all sorts of things can happen. Be able to solve for any variable. be able to solve for M2, G, L, mu sub k, M1, and V. Just use it as an exercise in algebra. Just be able to say, all right, I'm going to solve for mu sub k. How do I isolate it? Well, to isolate mu sub k, M2GL minus 1/2 M1 plus M2 V squared is equal to mu sub k M1GL. So M2GL minus 1/2 M1 plus M2 V squared divided by M1GL is equal to mu sub k. And you do the same thing for all of the other variables. Be able to solve for length, M1, M2, V, all of them. What could happen is, another thing that could happen is I don't give you the specific masses. But what I do give you is I say 4 times M1 is equal to M2. So if that happens, I would use this as the core equation and go 4M1GL, I just substituted 4M1 for that, minus mu sub k M1GL is equal to 1/2 4 M1 plus 4M1 V squared. This gives me an M1GL 4 minus mu sub k equals 5M1 over 2 V squared.
So would you not give us M1 and M2, or would you just not?
Correct. I wouldn't give you any of them. But it doesn't matter. And why is that? Because they cancel. You substitute it in, you factor out as much as you can, which is typically it'll be all of it, and then they cancel, so it disappears. And so a lot of people will lose their ever-loving minds by me not giving them the specific masses. And my only response will be, it is a correctly constructed problem. Just be able to solve for any of the other variables that I give you. So now it's down to GL, mu sub k, and V. Solve for any of those others. And that's it. Really, it's just being able to understand how to set this up. Do not, I repeat, and I'm mostly speaking to the people watching this, do not magically go, poof, there it is. A miracle occurred and an equation just appeared out of nowhere. You should be able to derive it. So be able to go from here to there, which isn't really very long. I mean, it's just a couple of extra lines. But you have to understand all the parts that lie within it. Yes?
Could we do like a rotation where alpha is not equal to 0? And like you said,
Well, the ones where alpha isn't, say that again.
but it has like
A funky geometry?
yeah, like when you said binomial.
Okay.
So you said we could be able to derive that first equation with the star from
Yep.
the one in black.
Yeah. Start here, get to there.
So if we don't write like the first 3 lines of black, it would be
And I need to see something like this set up as well. All right. All right, funky geometry. Or actually, I'm going to draw it bigger. just so that we can really see what's going on. So there is a disc, a 50 kilogram disc. The radius of the disc is 4 meters. Now in red, what I'm going to do is I'm going to draw my stick. The length of the stick, L, that L is 7 meters, and the mass of the stick is 20 kilograms. At the edge of the disc, that force is 500 newtons. From rest, how many turns will it make in 20 seconds? So what this is, it's a rotation problem where alpha is not 0. So if the rotation problem where alpha is not 0, the sum of the torques is I alpha, and theta is equal to theta naught plus omega naught t plus 1/2 alpha t squared. It's at rest, omega naught is 0. The initial position is always 0. Theta is 2 pi n. So 2 pi n is equal to 1/2 alpha t squared. Now I don't know my alpha just yet. I know t and I don't know n. The only thing I can really do is go alpha t squared over 4 pi. I need to find alpha. To find alpha, I really need to find moment of inertia find me first. Now the sum of the torques, torque by definition is just F times the R distance. In this particular case, this distance D is the radius of the disc. So really the torque is equal to F times R. And F times R is equal to I alpha. And alpha is equal to F R over I. What we're going to do is we're going to solve for alpha and then plug it in here. But I need to get the moment of inertia. The total moment of inertia is the moment of inertia of the disc plus the moment of inertia of the stick rotating at one of its ends. Now the moment of inertia of a disc is 1/2 mr squared. The moment of inertia of a disc, of a stick, around its center of mass is 1/12 ml squared. We've got to use the parallel axis theorem because to get the moment of inertia about a stick at the edge, or one of its ends, is the moment of inertia of the center of mass plus md squared. So this is 1/12 ml squared plus mass of the stick times d squared. D is the distance from, oh, this is not to scale. Oh wait, it kind of is. D is from the center of mass of the stick to the rotation point, which is here. If the stick's length is 7 meters, what's the distance from its center of mass to its end? 3.5. Just take it and divide it by 2. So this becomes 3.5. So the moment of inertia total is 1/2 mass of the disk, 50, r squared, 4 squared, plus 1/12 mass of the stick, 20, L7 squared, plus mass of the stick again, 20, times 3.5 squared. And that will give you $726.67. Because I intentionally made, let me redraw this thing. And I'll try to draw it to scale. Well, I tried. That radius is 4. This length is 7. What's half of 7? 3.5. It's definitely not to scale. So 3.5. So you have to use 3.5. 3.5 is the distance. If it was an 8-meter stick, half of 8 is 4. So then the center of mass of the stick would be at the edge of the disc. But it's not.
Oh, so you said it's not all the way at the end. I see now.
Yeah. Now that I have the moment of inertia, I can get alpha. Alpha is the force, 500, times the distance, which is 4, divided by moment of inertia, 726.67. .75 radians per second squared. That leaves me with only finding N. N is 2.75. T is 20. Divided by 4 pi. $500 is the force, which was listed there. Yeah, 500 times 4. $87.5 times. So yeah, it's gonna we're gonna have to be ready for weird geometries. Not just simple disk or a stick or a point. It's going to be a combination. Okay. That, I think, is it. Any last questions? Yes?
On this problem, is the stick attached to the disc? Or
Yes.
sitting on top?
It is fixed to the disk. For something like this, it will be fixed. They will not be allowed to slide.
Okay.
Yes?
Is there ever going to be a problem where omega is gonna be not zero, or maybe not in this case.
No, I'll keep it that simple. Yeah, I'm trying to do that.